This is a ground vehicle made using Jetson Nano ROS platform. Here I have taken a square piece of plywood on which the power supply, the batteries, the Jetson Nano and an emergency switch is fixed. This is the view from top. Here I have taken a pair of 12 volt 6 ampere batteries. An emergency switch is fixed in series to the battery and the motor driver. The DC geared motors are fixed onto the base and a pair of cast wheels are attached onto the front. Now the base view. Here I used a pair of DC motors, geared motors of 12 volts. They are connected onto the motor driver Sabertooth. This is a Sabertooth motor driver. The data is given through this USB-B cable. It is connected to the Jetson Nano. The DC motors are connected to these points, and the power from the battery is connected to these points. Now these are the dip switches which serves the purpose of shifting to different control modes. Now from this point we can take a 5 volt and a ground which is used here to power the Jetson Nano. Actually, when we use the serial port connection, we are giving the signals to this S1 and S2 and to the rest of the points, but in our case we are using the USB-B cable. This is the emergency switch. On pressing this, the power supply from the battery is disconnected and now the Jetson Nano is switched off. On releasing this switch, the power comes back. Now we can open the Python program in gedit. Here the first line states that it is a Python executable file. We are using Python 3. Then we are importing few modules. The Sabertooth for operating the Sabertooth motor driver, geometry messages for accessing twist messages, ROSPy for accessing the ROS library, then serial.tools.list ports for dealing with the ports. Then we extract the list of ports to the variable port list. Then we check whether Sabertooth is present in the ports. Then we are initiating two variables for assigning the speed of motors. Now Saber points to the Sabertooth motor driver, so we can access the motor driver using Saber. Then we have defined few functions like translate, callback and a listener. On moving to the main function, there the listener function is called. There it initiates a node named listener, which is set to anonymously true. The node is subscribed to the topic joy talob cmdwell using twist type, and whenever a value reaches here, the callback function is initiated. The rospy.spin keeps the node from exiting until it is properly shut down. When an input value is received, it directly calls the callback function. This line resets the speed value sent to the motors by the Sabertooth after executing each input, or else the motor will be continuously moving in the position received as per the last input. Now the value of the speed and angle is found using the data received from the joystick. X is the linear data and Z is the angular data. The maximum extreme values of speed which can be given to the Sabertooth is -100 and 100. Since the motor here has around 370 rpm, I am scaling the speed to 50%, that is -50 and 50. So the translate function performs the scaling using the linear equation y is equal to mx plus c. Now we need to cap the value of the speed to 50 and -50 respectively. Then this part of the code was actually meant to print whether the robot is turning left or right. Then it prints the necessary values whenever an input is received. Now we have to initiate the ROS master. Then we have to load down the ROS master URI, since the Android mobile app will be connecting to the robot through that address. Now we have to open a new terminal and open the Python executable file. Now when the Android application is connected to the robot and an input is sent, the corresponding values will be printed on the screen. Now that the Python program is running inside the Jetson Nano, we can connect and control the robot using the Android app. ROS Control is an Android app available on the Play Store. Here we have to add our robot. Previously we discussed about the ROS master URI, and we have to type in the same ROS master URI for connecting the bot. Now that we can see the signal and the bot is connected to the Android application. Now the control panel is opened and we can control the robot using the joystick. Do keep in mind that the robot and the Android phone is under the same Wi-Fi.